fellow YourMathGuru.com members. Here's a great geometry problem without deep hidden tricks. We have an equilateral triangle ABC whose side has a length equal to 2 units. A segment, DE, inside the triangle is a parallel to the triangle's base. The area of triangle ADE is equal to the area of trapezoid DECB. What's the length of segment DE? Okay, clearly the first thing we can do is to calculate the area of ADE. We'll call it A1. A1 is equal to half of DE H1, where H1 is the height of triangle ADE. Next, we calculate the area of trapezoid DECB. That's A2. A2 is equal to half times B1 plus DE times H2, which is equal to half of 2 plus DE times H2, where H2 is the height of trapezoid DECB. Now then, here is the key focal point of the problem. We know that H1 plus H2 is equal to the height of the equilateral triangle ABC. We'll call it H. But if we think about it, H is one of the legs of the 2 right-angled triangles that comprise triangle ABC. This would mean that using the Pythagorean theorem, we would get h squared plus b1 over 2 squared equals 2 squared, which eventually simplifies to h equals square root of 3, which is h1 plus h2. Furthermore, we also know that if the smaller triangle and the trapezoid have the same area, then they're each half of the large triangle's area. Thus, A1 is equal to half of DEH1, which is equal to half of 2, square root of 3, which is half of square root of 3, from which we can get H1 to use it in the expression of the area of the trapezoid that we recently provided. H1 is equal to square root of 3 divided by DE. Knowing that H1 plus H2 is equal to square root of 3 from the calculation of triangles ABC's height that we just did, we also can say that H2 is equal to square root of 3 minus H1, which is square root of 3 divided by DE. And now we can substitute in the expression for the area of the trapezoid, A2. A2 is half of 2 plus DE times H2. That's half of 2 plus DE times square root of 3 minus square root of 3 divided by DE, which is also equal to half of the large triangle, or half square root of 3. Therefore, half square root of 3 is equal to half of 2 plus DE times square root of 3 minus square root of 3 divided by DE. Simplifying, we would obtain DE squared is equal to 2, DE is the square root of 2. See? The problem does seem at first that it is reasonably simple and straightforward, but there is a procedure to it, and we must understand the critical need to take a step-by-step approach leading to its solution. YourMathGuru.com understands that some individuals can feel lost and hopeless at geometry problems such as this one. All that math help needing people have to do is to take it easy. Lay out the information that we know and analyze the problem closely so we can tackle it without growing frustrated. Above all, practice constantly. Another example of a geometry problem that requires nothing more than patience and a short analysis is this one. An equilateral triangle with side 4 has an inscribed square. Find the area of the shaded region. Once again, identify the pertinent information, along with the information that you need to obtain in order to determine the final answer. The side of square is A. Let us use the concept of similar triangles. Uppercase base divided by uppercase height is equal to lowercase base divided by lowercase height, which establishes a proportionate relationship between the big triangle and the smaller one on top of the square. From visual inspection, lowercase height is equal to uppercase height minus A. The big base, uppercase base, is the triangle's side, which is 4, and the big height, uppercase height, is determined from the Pythagorean theorem applied to the triangle. Side squared is equal to base over 2 square plus height squared. In the equilateral triangle, base is equal to the side. Hence, 4 squared equals 4 over 2 squared. Plus height squared. Height squared is equal to 12, hence height, uppercase height, is 2 square root of 3. That's the height of a large triangle. Then we substitute in the similar triangle equation recently mentioned. 4 over A is equal to 2 square root of 3, divided by 2 square root of 3 minus a. That leads to a with simplification from doing it slowly and carefully equal to a square root of 3 minus 12. Thus, area of triangle is 4 the base times the height, 2 square root of 3 divided by 2, which is equal to 4 square root of 3. An area of square is simply a squared simplified carefully and slowly would yield 336 minus 192 square root of 3. Shaded area is the difference between the two. The final answer is 196 square root of 3 minus 336.